Welcome back. So we will be looking at strings for the next series of lessons, and we will start with characters and understand how they are managed in a C program. So let's look at the program as it stands right now. Notice I have this function getCh with a printf statement right above it. This two lines here are a substitute for the system pause we've had in previous programs we've written. This getShe simply will require that you enter a character at the prompt on the console while the program is running. So let's see quickly how this behaves. So I'm just going to compile and run this. And you can see now the press any key to continue statement, which is really a string. This is a string, literal, that's written within the printf as an argument, okay? And that's what's being printed out on the screen. And notice now that I have a prompt blinking right here. And basically, it's blinking right at the end of this string here. There is no /n, so there is no escape character to get a hard return in this case. So everything is on the same line. So right now, getShe or getCh is waiting for us to enter a character, including a spacebar. So if I do that, notice it catches it, and the program ends, returns 0 back to the operating system. Okay? Now, this technique is probably more useful if you're dealing with an operating system that does not understand the system pause command, right? Specifically pause, which is a DOS command. So this would be fine in a Linux environment or a Unix environment. And obviously it's working as well in a Windows environment as it is right now. Good. Now let's get to the business of understanding what a character is. So char is a data type, and then you can declare a variable of type character. So let's call it letter. Okay, so the letter is the variable name. Then you can assign it a value if you want to, so uppercase G, okay? And then if you want to print this, simply printf letter has %C, so give me a new line here, this character in it, so letter. Okay, well, let's see how this works. So compile and run. Okay. All right, so now we understand the basic utilization of a letter variable by, in this case, I initialized it, so you declare and assign a value at the same time. Can we have one where we assign the value at runtime? Sure. Let's do another one. Char myLetter, so another one. And this time, I'm not going to initialize it, and I'm going to ask the user to go ahead and enter a value for that. So enter a character. Okay, so now scanf, and that would be a %C and % myLetter. Now we can go ahead and print what we have. myLetter has this value, %C/n, myLetter. All right, let's compile and run this. As you can see, the G, which we've initialized, letter with, not a problem. It printed it out. Now it's asking me to enter a letter, and I'm going to type W. And myLetter has W in it. Fantastic. So now we understand how to do it at compile time, assign a value, or at runtime. So this is at compile time, which means in the source code itself, you assign a value to a variable. Runtime means you can't predict what the value is until you run the program, right? So you're going to have to go through scanf. The prompt is going to appear, and you're going to have to enter the value of myLetter while the program is running. So today you might enter W, tomorrow you might enter O or P, etc., etc. Okay? All right, so is there an alternative to this, to a character, right? In case you want to enter more than just single character or simply a character. Yes, you can have what we call a string. But a string really is a collection of characters. So it starts with char, and then you can give it a name just like any other variable. And let's call it my string1 for now. But notice what I'm going to do. In this case, I'm just going to give it 10 spaces reserved as an array of characters. So 10 spaces, each one is a byte, since the size of a char is really a byte, right? So I have 10 bytes total reserved to store a string. A string will be a collection of characters. So how do you enter data into this? You could enter it one character at a time. You could enter it all at once. Okay? So one way to do this, you could say something like this, printf, enter a string. Okay, so let's go ahead and enter a string. And we're going to investigate the content in that string in a minute. And let's say we do this, scanf. Now, to enter a string, you basically use the %s for this purpose. And you're going to write the name of the array. You don't put an %, right? Because the name of the array is the actual first address of this whole string array. So my string. Okay, now we want to see what we typed in. And now as long as you didn't type more than 10 characters, you're good to go. So printf, you entered. And we're going to do a %s /n, and that would be my string. Now, we get to see the strengths and weaknesses of this syntax in a minute. So let's go ahead and run it. And at runtime, we will be able to see what's going on. My string1. I named it my string1. I guess I'm planning on having my string2, etc. as examples. So let's go ahead and compile and run. There you go. We're good to go. All right, so enter a character. Let's put a T there. Now it's asking me to enter a string. So this is going to be the interesting thing. I'm going to type Bob, and you entered Bob. Not a problem there. As you can see, it can step through each one of these characters and print it out. But did it really print all the characters? Okay, so what I'm going to do now is write a for loop that would show me all 10 characters, what's in them. For that particular, even if I entered Bob. Okay, so let's go ahead and do that. Let's do a for loop here. And let's create a variable I, or count if you want. And then let's do a for loop for I equals 0, I less than 10, I plus plus. I want to see what's in that string. So we're going to do a printf and %c. We want to look at the character that's in there, and then give me a space and comma. Now watch this. My string I. Now remember my string1 I. Remember one thing. This is still an array, so you can still access each array member through its index. Okay? All right, well, let's go ahead and do this. Compile and run. And let's enter the letter W there. Let's enter Bob again. Okay, and let's see what happens. Now, if you notice here, we have Bob. The rest of the stuff is garbage. Now, but we do see a blank here. Let's do another run this and put something a little bigger. Let's run it, other than Bob. And let me just type an E there for that one. And I am going to type Baltimore. Okay, now watch what happens right after Baltimore. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have a little space here. Okay, good. So we know we pretty much reach the max. Okay, even though you gave it 10 spaces, but the 10th space is occupied by something very important. We can't see it here. Let me go for a little less than Baltimore and see what that is. And notice before that little space that's in here, you had garbage. And let's see if we get the space plus garbage for something shorter than Baltimore. Let's try DC. Right, so let me run it. And again, and let me just type DC. Now, I want you to see what happens here. Blank. Now, a bunch of blanks here and garbage, whatever it is. Right? So, there's always a blank right after this. Something going on here. Okay? And we're going to learn that's called a null character being entered in there. Okay? So, that terminates your string the moment you've entered a value right here when you typed it. So let's see if you put a space actually yourself. Right? So let me just type that one. And let me just DCMD. I'm typing DC and Maryland, right? So, and notice I put a space there, and let's see what we get. We only get DC, and MD does not go in. And why is that? That's because I forced, by putting a space, a null character in there. And then it takes it that way. So MD wasn't even stored in this array. Okay, so it's very important to understand the limitations, as I mentioned before, of populating an array of characters as your pseudo string, okay, or an actual string. So as you can see here, by putting a space between these two, right, or if you enter the first name and last name with a space, you're going to lose the last name. Let's do it again, just show you the behavior of this. Okay, just R there. And Joe Willard. All right, so let's see what happens. So we get Joe. Willard disappeared. It went to bit heaven. And that's because of that space. Okay? Let's just type Willard and see what happens. Just show you, again, what happens at the end of Willard. Okay? So you've got all the characters in there, and then boom, space. And then whatever garbage is after that. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. And the rest were definitely the one right after it always is blank. Right? Okay, so notice here the syntax. How the data was entered. Now, what if I wanted to enter it one character at a time? Right, so that's something we're going to be doing for the next video. We're going to use a for loop, for example, to enter one character at a time and see if we can have a little better control over what gets stored in that string. I will see you then.